I'm going to start off this presentation with a cool video right here.
Now it's targeting 140. You can see the throttle's going to start working its way back. Wow. And then the target altitude is 2200. Oh yeah, it did it. Here's coming down. I lied. Back a little bit. Yeah, GPS is still guiding it back to the center. You can see this starts turning sideways. Still here.
Wait for aircraft and propeller to stop for exiting the airspace. Press the button on the seatbelt receiver to unbuckle your belt. Open the door. Pull the latch behind the handle while rotating the handle upward. Push the top portion of the door out.
So it'll run through that. The engine will be spinning off. And away you go. And then just go through this demo. As soon as they're done, you can go ahead. Reminder, hang on. Yeah, hang on to it.
Hello everyone, my name is Michael Johnston. Correct, cool video, right? And my presentation is on Garmin's new feature of the autoland. Takeoffs can be achieved by pilot and anyone learning how to fly easily. At cruise, it can be monitored by autopilot and managed by the pilots. Landing, however, is the most critical part of flight because of all the existing conditions that pilots face. It can be like the level of terrain, the weather, wind direction, airport location, and the airplane's condition to land or fly. On the other hand, it can be challenging to land because of the controls and features that the aircraft carry itself. Some planes are smart enough to notify a pilot if a step has been missed in a landing sequence. An example is the throttles are reduced, but the landing gear is not down and locked. They'll tell the pilot, "Hey, what are you doing? We're landing. we need those down." And some require more detailed instructions for pilots to land with the controls in the cockpit. I've seen a couple other YouTube videos. They're too long to be added to this presentation, but videos of people landing the aircrafts themselves, passengers, with instructions from the radio tower itself. Some airplanes can be achieved. Some are designed to try to make it as simple as it can. But for non-flying pilots, this is where this system comes in. It's a picture of an Airbus 320 right here. This is also another picture of the Airbus 320 with the lights, everything on, of course. Boeing 737-700. And that's the LRU from a CRJ-200. CRJ-200's got the same yoke features as the 737. So basically, and some aircrafts require more detailed instructions for pilots to land with the controls in the cockpit. So basically, for anyone to fly it without instructions by radio communication, the airplane would not have been able to land for that type of situation. In most cases, passengers would not know where to start when getting communication settled with the local airport tower radios. Most airline aircrafts are equipped with auto-landing features, but would be at a pilot's level of knowledge. An example of one of these features is in the LandCat systems. Older commercial aircrafts would have LandCats 1 and 2 systems. There's that picture of the LRU right here. That'd be part of the CRJ-200. Those aircrafts have different capabilities and equipment and components than the newer aircrafts. But newer ones, would have the LandCat 3, Cat 3A, and Cat 3B. The difference is that these systems would activate at certain descent altitudes when landing, basically prior to the runway. The less the system goes down, the more controls a pilot would have to have in order for that system to line up. If it makes sense with landing, or the term would be marshalling. But for this presentation, we will look at the AutoLand feature of Garmin itself. The project of this AutoLand for Garmin started in 2011 with a Garmin engineer testing some algorithms that can make AutoLand possible. In 2014, Garmin accomplished its first auto-landing in a Columbia 400 piston single. Sorry, I don't have a picture of that one. I forgot to add that. In September of 2015, Garmin got involved with the goal of certifying auto-land production airplanes, so that Garmin has flown more than 800 autolands in various airplanes, including 200 in the M600 airplanes. Let's see, I got a picture right here of that. The M600 airplanes made its first auto landing in September of 2018. The big goal of this auto land is to rescue the airplane and passengers in the case that the pilot or pilots are incapacitated or weather conditions present no other safe options for landing. Cases like that is the only reason why any passenger would try to land the aircraft themselves. Airplane models Cirrus, Vision Jet, and M600 has received their approval from the FAA to use this feature for flight operations. And that's Cirrus 200 right there. The Garmin AutoLand system is a part of Garmin's Autonomy family of automation products, which includes electronic stability and emergency descent mode. The AutoLand is designed to safely fly an airplane from cruising altitude to a suitable runway, then land the airplane and apply brakes and stop the engines, depending on the airplane. AutoLand can switch on also anti or DI systems if necessary for icy snow conditions, More than 100 Garmin engineers have worked on Autoland, including a team of human factor experts. They had to carefully design the system so that a non-flying passenger can not only switch it on, but fully understand what is happening during the Autoland event.